Hello everyone, Integrals 1, day number 7. This is the last video lesson for this chapter. The topic for today is integration by trigonometric substitution. Today I'm not going to do a proof of why, I'm just going to give you the how. Okay, so when the integrand contains a quadratic radical expression, use one of the following trigonometric substitutions in order to integrate. So if the integral contains the square root of a squared minus x squared, you're going to use a sine of u. If your integral contains square root of x squared minus a squared, you're going to use x equals a secant u. And then the third option, if it contains square root of a squared plus x squared, use a tangent of u. Now, before we get started, I do have to introduce you to one special, well, it's not a special integral, but it's one that takes a specific type of technique. If I wanted to integrate the function secant of x, okay, so we're going to use a u substitution. However, secant can be written as 1 over cosine x. But our substitution, if we choose to use cosine, has issues, right? Because then I take the derivative of cosine and I get sine, and that's nowhere to be found within that integral. Okay, so what we're going to do is we're going to use the tricky strategy, which is used many, many times in math, and we're going to multiply by 1. We're going to multiply by secant plus tangent on the top and the bottom, numerator and denominator. And I'm going to do a quick simplify, distribute. So I'll have secant squared x plus secant tangent over secant x plus tangent x dx. Now I can use a u substitution, and I'm going to set u equal to the denominator secant x plus tangent x, and see what happens here. What's the derivative of tangent x? Well, it's secant squared x, and the derivative of secant x is secant x tangent x dx. Nice trick. This trick can actually also be used to integrate cosecant x. All right, so let's just finish it off. So if I do a direct substitution, the numerator and the dx disappear. So I get 1 du. And the denominator, of course, is u. So I'm going to get the natural log of the absolute value of u, which is secant x plus tangent x plus c. There you have it. That is the integral of secant of x. Not one that's going to show up very often at all. It might show up a couple times, or one like it, in our lesson notes today, as well as our lesson homework. However, I've seen it almost, I don't think I've ever seen it on an exam, but doesn't mean it can't happen. So beware, that's one special integral that you might want to have in the back pocket. All right, let's get into subtrig substitution. Okay, so here I have the integral of the square root of x squared minus 9 over x with respect to x. Now, I can't use a u substitution, but what I'm going to first do is put it in a form that allows me to identify a. So it'll be x squared minus 3 squared inside a square root all over x with respect to x. Now that, I see the square root of x squared minus 3 squared, which is an example like example 2. So that means I'm going to write that x equals 3 secant of u. Okay, now with regards to that, now what I can do is take the derivative, which will be 3 secant u tangent u du. Okay, now I'm going to do some side work here for a minute, but first I'll sub this in, and then I want to work back to what I've got written here in red and do some modifications that we'll need later on. So this will be the integral of x squared inside the square root. Oh, let's try that again. That's better. So x is 3 secant u squared minus 9 over x, which is 3 secant u, times dx, which ends up being 3 secant u tangent u du. Okay, before we do any simplifying there, I want to work my way back over here. So if x is 3 secant u, then that means that secant u is equal to x over 3, which means that the cosine of u is equal to 3 over x. So I'm going to sketch in the first quadrant this angle u, where its cosine is 3 over x. And I'm going to find that third side. It's going to be useful later on, which would be the square root of x squared minus 3 squared. So you can kind of see where all of this is coming from. Okay, now let's table that for a second and work back here with our integral. Okay, so I'm going to see that I'll have a reduction of 3 secant u with 3 secant u. I'm going to clean up everything inside the radical here real quick. I'd have 9 secant squared u minus 9. So I'm going to pull out a 9. So I'd have secant squared u minus 1. And the outside I have tangent u du. Okay, so the square root of 9 is 3. So I'm going to pull that out in front. And secant squared u minus 1 is actually equal to tangent squared u. So I have 3 times the integral of tangent squared u times tangent u du. The square root of tangent squared is tangent, and tangent times this tangent is tangent squared. Now, that's going to be difficult to integrate. You could try integration by parts if you wanted to. I'm not going to do that. I'm actually going to use the shortcut I used earlier and write tangent squared as secant squared u minus 1. All right, because I know that the integral of secant squared is tangent u, and the integral of 1 is u. All right, now what I need to do is I got to put this back in terms of x. So that's going to bring me back over here to my picture. So I have an image, and I want to know what the tangent of u is. Well, the tangent of u would be the square root of x squared minus 9 over 3. Okay, so that would mean I've got 3 times tangent of u, which is square root of x squared minus 9 over 3. Those 3's will reduce in just a minute. Now I got to find u. Well, I could represent u in many different ways. I could represent u using an arctangent, an arcsine, an arc cosine. Doesn't matter which one of the 3. So I'm going to choose to use cosine. It'll keep me from having to write too much. So if the cosine of u equals 3 over x, then u equals the arc cosine of 3 over x. So I would have u equaling the arc cosine of 3 over x plus c. So let's simplify this out, put it in a different color here. The 3's would reduce on the first term, so that'd be x square root of x squared minus 9 minus 3 arc cosine of x over 3 plus c. There you have it. That's the integral of the square root of x squared minus 9 over x. Let's go through another question here on the next slide, but we're going to use very similar steps in the same process. Okay, here we are. We got another example. Square root of 1 minus 4x squared over 5x dx. So here what I need to do, again like I did before, is I need to rewrite this in a form that allows me to see a squared minus x squared. Right now I don't have x squared alone, so I'm going to pull a 4 out of both terms. So if I pull a 4 out, That means I'm going to have 1/4 minus x squared. Okay, over, of course, 5x dx. So if 1/4 is equal to a squared, then a must equal 1/2, right? Okay, so I've got, in essence, let's rewrite. I'm going to pull that 4 out, which when it comes out of the square root becomes a 2. And then rewrite this as 1/2 squared minus x squared. I'm going to pull out the 5 as well. And just put that over x. And dx at the very end. Okay, so what form does that fit? Well, that fits the first form, where in our case we would have x equals 1/2, right? That's a sine of u. So dx would equal 1/2 cosine of u du. All right, so I'm going to do a substitution over here in the integral, cleaning some things up, and then we'll go back to our red script on the side there. Okay, so I've got what would be the square root of 1/4 minus, if I square 1/2 sine u, I would get 1/4 sine squared u. Okay, there's always a trig identity that'll show up. I'm going to divide by 1/2 sine of u and multiply by 1/2 cosine u. So in this case, I will likely get some kind of Pythagorean identity involving sine squared, cosine squared, 1, all that good stuff. Okay, so let's clean this up again. It looks like the half reduces here. I don't get a reduction like I did on the last one, where the denominator here, sine u, doesn't reduce with cosine u, but we'll see something else happen here momentarily. So I get 2/5, and I'm going to factor out that 1/4. Factoring out the 1/4, I'm going to get a 1/2 coming out of the square root there. So I will be left with the square root of what would be 1 minus sine squared. Well, we know that 1 minus sine squared u is equal to cosine squared u. So I'm going to get cosine squared u over sine u times cosine u du. All right, so what does that come out to be? Well, these 2's would reduce here. I get 1/5 integral. Square root of cosine squared is cosine, but cosine times cosine is cosine squared. Just like that. Okay, so where do we go from here? Well, what I would do is I would rewrite this as, again, 1 minus sine squared u over sine u. Now I'm going to pause there, and I'm going to work over on this right side like I said I would with the red script. Come up with the triangle that we're going to work with, and then we'll come back and work with that identity that we have right now. Okay, so looking over to the side here, if x equals 1/2 sine u, then sine u equals 2x. All right, so I'm going to sketch that. Here's my angle. Here's u. The sine of u equals 2x over 1. So that would mean that the adjacent side to u would be 1 minus 4x squared, which, of course, we see shows up in our integral. Okay, so the other thing I'm going to do is I'm just going to rewrite u. Because I used it on the last one, I'll likely use it on this one. We'll see. Maybe not. But u equals the arc sine of 2x. Okay, we'll see if that shows up here in a minute. Maybe it doesn't, maybe it does. Okay, so let's work this bottom portion here that we had rewritten. So if I were to rewrite 1 minus sine squared over sine as 1 over sine minus sine squared over sine, what I get is cosecant u, which we integrated secant u earlier. We're going to integrate cosecant u here in a minute. minus sine of u. And I know the integral of sine of u. So this is going to be the integral of cosecant of u du minus the integral, I got to distribute that 1/5 to this one as well, of sine of u du. All right, so we're going to do a little work with cosecant of u, and then we can do the easy work with sine u. All right, so I'm going to do a manipulation here like I did before, except this time I'm going to take cosecant of u and multiply it by cosecant of u plus cotangent of u. All right, on top and bottom. du. And then, of course, tag along the 1/5 sine of u du. All right, so in our integral here on the left, I'm going to do a u sub, actually a double u sub, and write cosecant of u plus cotangent of u. Notice in the numerator I would have cosecant squared plus cosecant cotangent. So the derivative of cotangent u is negative cosecant squared u minus cosecant, this will be the derivative of cosecant u, cotangent u. That'll be negative, right? So negative dw is equal to cosecant u, squared u, plus cosecant u cotangent u. All right, this is going to be great. So this will be the integral. Don't forget the negative. Bring that out in front. Negative 1/5. All right, the numerator is negative is dw, right? So we've got the integral of 1 over w dw. Cool. Again, minus 1/5 integral sine of u du. All right, let's continue. This is getting crazy. All right, so I get negative 1/5 natural log of w. Well, w was cosecant u plus cotangent u minus, and actually the integral of sine is negative cosine, so I'll just make that plus 1/5 cosine of u plus c. Now, we got to work with u. We got to find the cosecant of u, the cotangent of u, and the cosine of u. So let's resketch the triangle that we had from above. We said that the sine of u equaled 2x. Okay, so if the sine of u equals 2x, then we said that this adjacent side was 1 minus 4x squared, square root. So now we can come up with the cosecant, the cotangent, and the cosine. All right, so that will be, finishing this one up, real close here, the natural log of the cosecant of u. The cosecant of u is the reciprocal of sine of u. So that'll be, instead of 2x, it'll be 1 over 2x. Cotangent of u is the reciprocal of tangent, which will be square root 1 minus 4x squared over 2x. Plus 1/5, the cosine of u ends up being square root of 1 minus 4x squared over 1 plus c. There is the integral of the original expression. I don't remember what it was, and I don't want to scroll up, but we got it. All right, let's do one more example, possibly using maybe the third option. Okay, here we have it. The third option, and what we'll see here is that we have the integral of 1 over. I'm going to pull a 4 out of both of those. So a 4 will come out of the square root as a 1/2. Right? And so that will leave us with 9 plus x squared inside the radical. All right, so a will be 3, and we'll be working here with a tangent example. So x will equal 3 tangent of u. Therefore, dx will equal 3 secant squared u du. Now, if x equals 3 tangent u, then tangent of u equals x over 3. Let's sketch our triangle. I know I'm going a little bit out of order as I did earlier, but I don't care. So tangent is x over 3. Hypotenuse then will be 9 plus x squared. Square root. Perfect. Okay, so let's do a little work here. So this will be 1/2. Let's do some substitutions. That'll be 1 over, it looks like the square root of 9 plus 3 tan u squared, which is 9 tan squared u. And of course dx is 3 secant squared u du. Okay, some cool stuff will happen here. Let's see what it is. I'm going to bring that 3 out in front. And it's actually going to reduce with the 3 that comes out of the square root in the denominator. Right? So I'm going to get square root 1 plus tan squared u. Secant squared u du. All right, so the 3 came out. This 3 was the 9 that was a coefficient of both of these. Factored it out. Square root of it is 3, but it's in the denominator, so it's 1/3. So we'll see this reduce. So it'll still just be a 1/2 on the outside there. All right, and 1 plus tan squared is secant squared. All right, so I'm going to get 1 over the square root of secant squared, which is secant of u, times secant squared u du. All right, and that'll be, oops, forgot the 1/2. Don't forget that. That'll be 1/2 the integral of secant of u du. Now from the first slide, I believe that the integral of secant was ln of the secant plus the tangent plus c. So I took a big assumption here, and see the first slide if you want an explanation on how I got from the integral of secant to ln of secant of u tangent of u. So go ahead and check that out. Now I just need to know the secant of u and the tangent of u. So looking at this diagram, I already know the tangent of u. It's x over 3. I was given that earlier. The secant of u will be the reciprocal of the cosine. So the cosine is 3 over root 9 plus x squared. So the secant will be square root 9 plus x squared over 3. Therefore, the integral of the above function is 1/2 ln of x over 3 plus square root 9 plus x squared over 3 plus c. There you have it, guys. There is some trig substitution. Many times on exams when I have seen this come up, I have seen them give the substitution. So they might say using x equals 3 tan u. So I'm teaching you to the most conservative expectation, meaning I want you to be able to do all of it, whereas sometimes IB will give you a little bit of a hint. Okay, so hope it went well. Let me know if you got questions. We'll see you in the next video.